Welcome to LCGC and Spectroscopy's podcast, Priority on Purity. How pure is pure enough? This podcast is brought to you by Specs. Specs is a leader of quality, innovative, inorganic, organic, and custom CRMs. To find out more, please go to www.specs.com. And now, here's your host for this podcast, Patricia Atkins.
Hello, welcome to our podcast. My name is Patricia Atkins. I am the Global Product Manager for the Specialty Chemicals Division of Antilia Scientific. And specifically, we're here today and we're going to talk about Specs. Specs is a certified reference materials company that's been around for over 70 years. And I'm very happy today to talk to some of our lead scientists and experts at Specs. First, we have Dr. Alan H. Katz, the Director of R&D, and he's been with Specs for 6 years. Welcome, Alan. They also have then Dr. William Green, the Inorganic Manufacturing Manager, and he's been with Specs for about 9 years. So you're an old timer like me, Bill. I just actually celebrated 15 years at Specs. So welcome to you both. Thank you. Welcome to you both.
Thank you very much.
And I really am excited about this new product line that is going to be coming out of Specs soon. So this newest product line is our inorganic fine chemicals. Can you tell us about how this product line came to be introduced?
Sure. So as you know, we're a producer of certified reference materials, which means that we have to work with essentially the entire periodic table. And we found that if you want to make the best CRMs, you really need to start with the best raw material for that CRM. So, that means that you want your raw material for any particular element to have as little contamination as it possibly can from any other elements, right? If you're working with potassium, your customer just wants to see potassium. They don't want to see sodium. They don't want to see rubidium. Just potassium. So we really want to get as clean as we possibly can with every compound that we use. And there's really only a couple of ways to do that. Either you need to source an exceptionally clean raw material from a vendor that you trust, or you have to bring in a lower quality material and you have to refine it until it meets the purity requirements for CRM manufacturing. At Specs, we've learned that there's really no better way to do that than to take that on yourself, to prepare that material yourself, test it yourself, which will give you that confidence that it is as good as it needs to be to make a quality CRM. There's a lot of reasons to do this. Risk mitigation is one of them. You never know when a trusted raw material vendor is going to go out of business or when there's going to be a shortage of a critical raw material. In some cases, the quality, the grade that you need might not be available at all. So over the years, we've gotten really good at preparing and purifying, a substantial number of compounds for our CRM line. And we've gotten so good at it, and we've been doing it for such a long time now that we started asking ourselves, isn't this something that we should be sharing with our customers? So this project really grew out of our own continuous improvement processes.
Thanks, Bill. Alan, do you have any thoughts about our new line of products?
I think the levels of purity that we're talking about is amazing, especially given that I'm an organic chemist. So we're excited if we get 99.0% purity or something. But can you give me a better idea? Like, for example, how does a factor of 10 affect the quality when you go from 99.99% to 99.999 and compare that to going from 99.9 to 99.99?
So it's a substantial difference, Alan. The short answer about how much it matters, it really depends on the end application. But for the CRM industry, 99.9%, which sounds really pure, that's rarely acceptable. So what does 99.9% really mean, right? So when we say that, we mean that the material could have up to 1,000 ppm or parts per million. You might have heard this expressed as milligrams per kilogram of impurities in it. All right, and it doesn't sound like a whole lot, but in the CRM industry, it's huge. And those impurities will show up in your finished product, and they might affect the performance or the stability or the acceptability of that CRM for the industry. But if we add just one additional 9, and we go from 3 nines to 4 nines, now we've gone from 1,000 ppm of impurities to just 100. Now, that may or may not be good enough. We might have to add yet another 9. depending on what the material is and how those impurities are distributed throughout it. But you can see what a huge difference that 9 makes. And then if we move the additional 9, now we're at 5 9s. Now we've went from your 3 9s, 1,000 ppm of impurities, down to 5 9s and only 10 ppm of impurities. That's a huge difference in terms of just the raw number of material that you don't want in your starting material.
Wow, that's amazing. Okay, so how do you actually improve the purity of these incoming raw materials? I mean, the techniques that you use, do they vary from metal to metal?
Yeah, so we actually use a range of different techniques, and that depends on the nature of the material. What the element is, what form of compound it is, and also the degree of purification that we require. Are we purifying something starting at 98%, 99%, 99.9%? That'll influence the route that we go in terms of the purification process. In terms of processes that we use, it can include recrystallization, ion exchange chromatography, selective precipitation, extraction into a non-aqueous solvent, electrochemical refinement. We have a lot of techniques at our disposal. And every element is unique. So what works for purifying one element may not work for other elements, or even for the same element if it has a different set of impurities. So for this reason, we really need to have a broad range of techniques available and be relatively skilled in every one of them.
So I have
I
a
see.
follow-up question, Bill. So if you're really aiming for high purity of a raw material, that means you're really working with like high purity acids and high purity water. I happen to know at Specs we have a very large water purification system. Is that all part of the way that we treat raw materials that eventually becomes, in many cases, our standards?
Absolutely, absolutely, Patty. You have to keep in mind that when you're doing a purification, every reagent that you use should be contributing to the purity of your final product. So you don't want to take a really pure material and then treat it with a low purity acid or another low purity reagent, because that's not going to help you. It's not doing you any favors. So throughout the entirety of the process, we use either trace or ultra trace level acids. We use ASTM type 1 water. It's about 18 mega ohm. It's extremely clean water. And you have to take great care to make sure that you don't introduce any impurities in the process of trying to get rid of others.
Are there certain metals that are easier to remove impurities compared to others? Are there some problem children?
Oh yeah, absolutely. Some elements are pretty easy to separate from each other. Magnesium and calcium is just relatively simple to separate those two. You compare that with, say, hafnium and zirconium, which from a chemical perspective are virtual twins to one another, and that becomes extremely challenging. So, that's part of the challenge, but it's also part of the fun.
And I guess you like those challenges. You're always looking like the mad scientist cooking up your raw materials.
Yep, I sure am. And it does get harder the higher the purity level. So the higher you go, the harder it is to go any further in terms of getting the material more and more clean. So that's actually pretty intuitive when you think about it. When we increase the level of purity from 3 9s to 4 9s, we've removed 900 ppm of impurities. It's a 90% reduction. So to state the obvious, that means you've got 100 ppm of impurities left. Now, as the purity increases, the quantity of impurities that are available to be removed, it decreases, it goes down. And that makes the removal of the remaining impurities more challenging. First, because there just isn't as many of them left to remove. And second, because a lot of the techniques that you use to increase purity, they become less effective when the amount of remaining impurity becomes really, really small.
So how do you determine purity then?
Good question. So our primary determination of purity is done by inductively coupled plasma mass spectrometry, or ICP-MS. It's a really powerful, really sensitive technique that allows us to scan for small amounts of impurities across the periodic table. The ICP-MS analysis really allows for an incredibly low level of detection, down to the parts per billion, or ppb level, to give you a feel for just how small that is, just how good the resolution is there. That's like being able to pick out one drop out of an Olympic-sized swimming pool. Now, each material C of A has a complete listing of all the impurities that we've scanned for, and where applicable, the amount of the impurity that we detected. And we're also providing our customers with a full summation of all the detected impurities, which is how we calculate the final purity of the material.
So what do you think the importance of listing all the impurities on the cert is?
Good question. So if you have looked at some of our competition and what they provide on their C of A, you'll see that it's a limited subset of impurities. And is that enough? Well, it sure depends on your application. These compounds are designed for customers where they need to know exactly what is in what they're buying, where the purity grade alone is not enough. So, how could that interfere with a customer's process, or why might one 99.99% product not be equivalent to another one that has the same number of nines? Well, if you're in the pharmaceutical industry and you're working with, say, potassium nitrate, and it has 100 ppm of impurities, if that 100 ppm of impurities is all sodium, you probably don't care. It's benign, it's environmentally friendly, no big deal, right? But if that same 100 ppm of impurities is arsenic, that's not going to fly. You're not going to like that. So knowing what your impurities are and how much is present is just as important as knowing the overall purity.
So industries like pharma, semiconductors, are these your target customers?
Yep, those are two very good examples of places where these materials would really make an impact. Also, academic and industrial research. Any place really where your customer needs to know not just what's in their the product that they're getting, but how much of it, and a really broad picture of that impurity profile. And that's what we can offer that a lot of the competition can't.
So, Bill, how does the purity of the Specs new products compare to our competitors?
So it actually compares very favorably when we're talking about compounds of a similar stated purity and at a similar price point. What makes our products really unique and what makes them stand out from the competition is that detailed impurity profile that I was talking about a minute ago. We provide results for over 66 possible contaminating elements, which makes our certificate one of the most comprehensive in the industry.
Why do you think it's so important to list so many impurities?
Well, these are designed to impact the broadest possible number of customers that we can, and we don't really know at the outset what impurities a customer does or doesn't care about. I mentioned the sodium versus arsenic comparison a second ago, but maybe you're a customer who does care about sodium. Maybe you don't want to see any other alkali metals in your potassium. You can't know the customer's needs up front. And so being able to address whatever their needs might be, whatever they are, is a real advantage.
It doesn't really take additional work, does it? I mean, you got that information, you might as well provide it.
Well, that's another unique thing about being in the CRM industry is we have to scan our products for a comprehensive range of impurities anyway.
Right. Yeah.
So this is something that we do regularly, and we've gotten very, very good at this. And so we're just applying something we already know how to do well to our new product line.
So we're just starting out with a handful of compounds right now. Are there plans for other compounds? Can you give us some examples of what's on the radar?
Well, I don't want to spoil it too much. Keep an eye on the website, and you will see new products as they drop. We've started with a real small subset of materials because we're really focused on quality over quantity. As we bring each one of these new materials to market, we really want to make sure that we're meeting and exceeding our customers' expectations. And that means taking the time to conduct a thorough analysis of our entire manufacturing process, from raw ingredients to final product, before we launch a new material.
Well, Bill and Alan, this sounds really exciting. Is there anything else that we really should tell our customers and tell the podcast listeners about our new product line? Is there any points that we say, yeah, this is why we think you should come to us?
You're coming to a manufacturer who has a deep understanding of what purity and what cleanliness can mean to an end user. And because of that, we're in a great position to make a high purity product, because we do have that long history of evaluating materials for impurities from across the periodic table and determining when they matter, when they don't, and how to make the material cleaner.
Alan, any last thoughts?
I was going to say, Bill is an excellent inorganic chemist. I find it amazing. Every time I talk to him, he has something new to say, which I wonder, does anybody else even know that? So I think that's a big reason why these are really good products.
Well, definitely we have the team to make these new products successful.
Yeah.
I want to thank you both for chatting today, and thank you so much for coming up with this new product line. I'm sure our customers are going to be very interested in finding out more about it.
Thanks, Patty. It's been a lot of fun talking about it.
Yep. Thanks a lot, Patty.
You've been listening to LCGC and Spectroscopy's podcast, Priority on Purity. How pure is pure enough? This podcast is brought to you by Specs. Specs is a leader of quality, innovative, inorganic, organic, and custom CRMs. To find out more, please go to www.specs.com.